Okay, I know you've been anxiously waiting to find out what this first derivative test is. It's super exciting, and I know you've been waiting with anticipation. So now we'll get right into it. So, using the first derivative test. Alright, if we have the function f of x equals 2x cubed minus 3x squared minus 1. We're going to go through a bunch of steps here. So first, let's talk about the domain, because we want to know the interval that we're working on. So the domain of this function, anyone? Okay. You guys are still quiet. It's alright. Negative infinity to infinity. It's early, I understand. Alright, now the first derivative. Use our power rule. F prime of x is 6x squared minus 6x. Now let's find our critical numbers. Set the derivative equals 0. Critical values. Now you'll notice as I'm going through this and as I go through all of these, make sure that you're going, not only are you going through these steps, but as with a lot of things that we do in this class, keep your work organized. So every time I find my critical values, I'm going to label them and circle them so that I recognize those are my critical values. It's not just two random numbers that I found solving for x, or solving for when the derivative is 0. Okay. So now comes the actual test. I know, exciting, right? So what I'm going to do is I'm going to draw a line. And then I'm going to put my critical values on that line in order. So it's like a number line almost. Now I'm going to pick a value that's in the intervals, not including those critical values. So this is very similar to when you're solving polynomial or rational inequalities, in the fact that we're basically creating test intervals and we're testing those intervals using the critical values to separate the intervals. So I'm going to do -1, 1/2, and then 2. Now what I'm looking for is within this interval, so if I plug in -1 to the derivative, is the derivative positive, negative, or 0? Well, I know it's not going to be 0, so is it positive or negative? When I plug in 1/2, is the first derivative positive or negative? And when I plug in 2, is the first derivative positive or negative? Why do I want to know that? Because that's going to tell me if the function's increasing or decreasing. So if I plug in -1, so this work you don't need to totally have all the time, but for right now, since this is our first time, I'm going to show this work. So if I plug in -1, we end up with 12. So that is positive. If I plug in 1/2, we end up with -3/2. So that's negative. And if I plug in 2, and again, just to emphasize, we're plugging this into the second derivative. If I plug in 2, we end up with 12 again, which is positive. Okay, so now we can see that on this interval, -infinity to 0, the function is increasing. From 0 to 1, the function is decreasing, and from 1 to infinity, the function is increasing. So what does that tell us? Well, I know that at 0 is a relative maximum, and at 1 is a relative minimum. So now let's find what are those actual points. So f of 0 is -1, and f of 1 is -2. Now, here's the other part that we have to do. Remember, one of the very important things in mathematics is to be able to explain yourself or explain what you're doing and why. So whenever you're answering these problems, we're going to want to do something along these lines. And this is what you're going to have to do on an AP test as well. So since f prime of x is less than 0 on 0 to 1, and f prime of x is greater than 0 on 1 to infinity, the point 1, negative 2 is a relative min. And then I'm also going to do, since f prime of x is greater than 0 negative infinity to 0, and f prime of x is less than 0 on 0 to 1, the point 0, negative 1 is a relative max. Okay, that's the first derivative test. So if you're given the function f of x equals x cubed, I want you to go through the first derivative test process and find the relative maximums and or minimums. Pause the video, unpause when you're ready to check your work. Okay, so this should hopefully make sense because you should know what the function f of x equals x cubed looks like, and it should have been relatively quick and easy. But there are no maximums or minimums for this function. It is a strictly monotonic function. It is increasing the entire time. So first, the domain is all real numbers. The derivative is 3x squared. The critical value is 0. So then I do my first derivative test, and I tested -1 and 1. Both of those are positive. And again, think about what does the function look like. It looks like this. And 0 is like right there. So that's the point 0, 0. So there is no relative maximum or minimum. Okay. Last one. So here I want you to find or use the first derivative test. Given the function negative x to the 5th plus 5 halves x to the 4th plus 40 thirds x cubed plus 5. So go through the process for the first derivative test. Pause the video, unpause when you're ready to check your work. Alright, so here we should end up with a relative minimum at the point -2, -89 thirds, and a relative maximum at the point 4, 1423 thirds. So how do we get that? Well, our domain is all real numbers. The derivative is -5x to the 4th plus 10x cubed plus 40x squared. When I set that equal to 0, I can factor out a -5x squared, and then it factors into x minus 4 times x plus 2. Set each factor equal to 0. I get critical numbers of 0, 4, and -2. So I do my first derivative test. To the left of -2, I chose -3. I plugged in -1 between -2 and 0. I plugged in 1 between 0 and 4. And I plugged in 5 to the right of 4. So I got negative, positive, positive, negative. So at 0, although it was a critical value, it is not a relative minimum or a maximum. So I can see that at -2, I have a relative minimum. At +4, I have a relative maximum. So then now using my derivative speak, that's what we're going to call this, f prime of x is less than 0 on the interval -infinity to -2, and f prime of x is greater than 0 on the interval -2 to 4. Therefore, the point -2, -89 thirds is a relative min. F prime of x is greater than 0 on -2 to 4, and f prime of x is less than 0 on 4 to infinity. Therefore, the point 4, 1423 thirds is a relative max. So, we want to understand Rolle's theorem, but Rolle's theorem should be kind of common sense. The first derivative is positive, then the function is increasing at that point, and if the first derivative is negative, the function is decreasing at that point. We use that to help us with the first derivative test, which is looking for changes from increasing to decreasing and decreasing to increasing to tell us if we have a maximum or a minimum. That is the end of this part.